Hey, it's Mr. Russell. Let's talk about chemical equations. Remember that the reactants are always going to be on the left side and the products are always going to be on the right. The arrow in the middle means yields. We also need to obey the law of conservation of mass, which means that the same number of molecules on the left need to be on the same number of molecules on the right. A better way to say that is the same number of atoms on the left need to be the same number of atoms on the right. So we'll have to balance those using our coefficients. We also need to get familiar with these down here to and really get in the practice of writing the solid, liquid, gas, and aqueous. As we explore in chemistry and as we go farther this year, these will become more familiar and they'll actually become necessary. Also remember that when you balance an equation, you can never change the subscript. If you're doing that, you're changing the identity of the molecule. That's not allowed. Never do that. Only change the coefficients. You can that's just the number one rule of balancing equations. This part down here I'll point out is it says some redox reactions require a different method. That's for another video, and we'll be going over that, and that's a whole nother animal. So let's do 3 examples of balancing equations. If I have my first problem, how would I balance it? Well, I have 1 aluminum here and 2 chlorines here, and 1 aluminum and 3 chlorines. So I need to, what I'll try to do is I'll actually try to put a 3 here and a 2 here so that I would have a total of 6 on each side. Remember, you will take the, and that's exactly what I'll do. This I'll take the coefficient and multiply it by the subscript, and that will give my total number of atoms that are included. So that means that there are 6 chlorines here, 6 chlorines here, 2 aluminums and 2 aluminums. Next question: if I take dinitrogen pentaoxide and add water, and I get nitric acid, I should need a 2 on the other side to balance it all out. If I take lead nitrate plus sodium chloride, will yield lead chloride plus sodium nitrate. To balance that out, I need to add a coefficient of 2 in front of the sodium chloride and a coefficient of 2 in front of the sodium nitrate. We need to be familiar with creating our own chemical equations from words. So if phosphine is combusted in air to form gaseous water and solid diphosphorus pentoxide, I will need to look at my context clues. I know that my noun, phosphine, is combusted, so I know that I'm going to be adding oxygen to it. And it forms, so that will be my yield sign, gaseous water, that would be H2O with a gas on the end of it, and solid diphosphorus pentoxide. So my equation will look like this. I have my phosphine, and then add my oxygen, and then yields gaseous water and diphosphorus pentoxide. You would remember the Greek prefixes apply to this covalent compound. I suggest writing the equation first and then balancing it afterwards. You need to always double check that it's balanced when you write an equation. Another example is when ammonia gas is passed over hot liquid sodium metal, hydrogen is released and sodium amide, NaNH2 is formed as a solid product. So I know that ammonia gas is NH3 as a gas, and hot liquid sodium metal so sodium as a liquid, and hydrogen is released, so I would have a yield sign, and then hydrogen would be my product, and then sodium amide would also be a product. So my result would be just like what I said, NH3 gas as Na liquid, H2 as a gas, and then sodium amide as a solid. Okay, notice I'm putting all the state symbols here. Hey, let's learn and review a little bit about stoichiometry. Remember that you may or may not be aware of that the mole ratio is the moles required divided by the moles given. Take a second to review this stoichiometry question. You should know how to do this one already. What it's giving us is 5.38 grams of lithium nitride, and it's asking for the mass of ammonia. So I'll start with my known information in the top left corner, and I'll have to convert lithium nitride to moles of lithium nitride, my mass to moles, and then I'll have to convert moles of lithium nitride to moles of ammonia. This comes from the chemical equation. These numbers here come from the coefficients in the chemical equation. So the coefficient here is a 1, is an understood 1, and the coefficient here is an understood 1. You could actually move to any one of these if the problem asks for it, but it asks for lithium nitride and ammonia. Then I'll just convert moles back to grams. So this is a 4-step problem. When I take the product of everything on top and divide by the product on everything on bottom, punch it all in the calculator, and I get 2.63 grams. There are 3 significant figures. Let's do an example out of the textbook on chapter 3, page 133, problem number 126. I've modified it just a little bit. It asks us to consider the following unbalanced reaction. P4 plus F2 yields PF3. What mass of F2 is needed to produce 120 grams of PF3? So the first thing we'll do is we'll balance it, because an unbalanced equation isn't much use to us. So I'll just take the first one. I see there's 4 phosphorus here and only 1 phosphorus here. So let's try to put a 4 here and see if that'll work. If I imagine a 4, go ahead and imagine a 4 where my finger is. That means that there will be 12 fluorines. And so I could work that out, and I could put a 6 there. So let's go ahead and add a 4 here and add a 6 here. Double check. After you add some numbers, it's always good practice to double check to make sure it does balance, and that is balanced. I'm going to start with by underlining in blue my known information in the lab. This will be our experimental data. That'll be what we probably what we find in the lab, and this is the unknown information is what we're trying to prove, what we're trying to see. So, and this is our unknown information underlined in red. So let's go ahead. And take our known information and start our stoichiometry. I will move it up so you can still see, but that will be 120, and remember that decimal place is important. PF3. I went ahead and converted to moles because that's probably what we're always going to have to do. So now when I do that, I'll have to insert the molar mass. Remember what the G stands for? It stands for go to the periodic table. So I'll have to look at the periodic table for phosphorus and fluorine. I'll take one phosphorus and add it to 3 times the mass of fluorine and calculate that now. And when I do that, I get my molar mass for phosphorus plus 3 times the molar mass of fluorine, and my total molar mass is 87.94. That's how many grams are in 1 mole. Now I'll go ahead and switch my moles to my moles of my fluorine gas. This is comes from the chemical equation, and it will be I'll use the coefficients here. So the number that goes here is going to be the 4, and the number that goes here is the 6. And now I'll just convert moles to grams. So I'll take moles of F2 and take grams of F2. The 1 goes with the mole on this one. And I'll have to go to my periodic table again. I'll take 18.99 times 2 and give me 37.98. A word of advice: when you use the molar masses and you look up your data on the periodic table, sometimes you'll get a lot of decimal places. You can approximate to 2 decimal places. That's just perfectly fine. There's no need to be super precise. This is just high school / beginning level college chemistry. So now I'll take the product of everything on top and multiply those together. 1 times 6 times 37.98, and I'll divide by the product of everything on bottom. Notice I'm putting parentheses on the bottom. On these TI-83s, they are really finicky if you don't put the parentheses and respect the order of operations. And I will get 77.73 something, okay? So let's go back to our original problem, and we started with 3 sig figs here. So let's make sure we have 3 sig figs in our answer. That'll make 77.7 grams. F2. And that's my answer. Okay guys, thanks for watching. We will start the day after this video is due with this problem, and it helps if I give you the equation. Here's the problem number, and we will start with this one. So give it a think as you when you come to class.